All right, chemistry, let's take a look at part 2 of our video lecture for our combined sections in chapter 6, sections 3 and 4. Here we're going to look at section 4, metallic bonding. So we've done a general introduction to bonding. We've done bonding we just did ionic bonding in depth. Type of bonding left, metallic bond. So here today, I want you to be able to describe the electron C model. I want you to be able to describe or explain metallic properties, and those metallic properties are malleability, ductility, luster, and conductivity. And then lastly, I want you to be able to explain why hammering flattens metals but shatters crystals. Now, I would like to point out that all of these objectives find their foundation in the sea of electrons model, so that's going to be central to anything you do or talk about with regard to metallic bonding. But before we get into metallic bonding, I want to go back a slide or two, and I want to remind you of this action right here. So we have our solid ionic crystal, like what we saw with the ionic solid. Sea of electrons and the positively charged cations that we call metallic bonding. But why do metals have such high melting points? The properties of metals, like melting point, are related to the structure. Metals often have very, very high melting points, and boiling points. Gold, for example, has a melting point of over 1,000 degrees Celsius and a boiling point of almost 3,000 degrees Celsius. This property, high melting and high boiling point, is due to that strong attraction between the positively charged metal cations and the sea of electrons, which is negatively charged. In metal extraction and other industrial processes, furnaces often run constantly to maintain those high temperatures needed to work with molten metals. And this is why whenever you see a representation of metallurgy, it's always incredibly hot. But why do metals conduct heat and electricity? So when we talk about conductivity, we're talking about conducting heat and electricity. While those delocalized electrons in the metallic bond in the sea of electrons allow metals to conduct heat and electricity. So it all comes back to that sea of electrons. For example, when a metal is heated, the delocalized electrons gain kinetic energy. In fact, they are pretty much the only things that can move for the most part, so if anything's going to gain kinetic energy and move, it's going to be the electrons. These electrons then move faster and so transfer that gained energy throughout the metal, meaning that the heat or electricity will transfer throughout the rest of the metal, meaning it conducts heat effectively. This makes heat transfer in metals very efficient. The delocalized electrons also conduct electricity through metals in a similar way. Metals are usually strong but not brittle. When a metal is hit, the layers of the metal ions are able to slide over each other so the structure does not shatter. So we have our normal lattice structure right here. If a force were to come in and shift everything to the right, like we saw earlier in our ionic solid, there was a shattering effect because oppositely charged ions would line up. When we move all of these cations to the right, when you shift them to the right, the sea of electrons moves with it, right? Because to maintain that electrostatic attraction, these negatively charged electrons stay in between the cations, and so there's no lineup of repulsion. In between all of these positively charged cations, the sea of electrons and its negative charge remains. Therefore, the electrostatic attraction remains, and it does not shatter. The metallic bonds do not break because of, again, these delocalized electrons. They are free to move throughout the structure. This also explains why metals are malleable, which means easy to shape, and ductile, which means that can be drawn into wires. All right, these are some check for understandings that I want to ask you. True or false for each of the following. Metals have a lattice structure. That is true. Metallic bonding is an attraction between metal ions. That is false. So between metal ions and the sea of electrons. Electrons have fixed places in the sea of electrons. That is false. They are delocalized. Metallic bonding allows metals to conduct electricity. That is true. Metallic bonding allows metals to be bent. That is true. Metallic bonding lowers the melting point of metals. That is very, very high melting point. All right, chemistry, I will see you next period.